Hello there, Mr. Sutton here, bringing you the Algebra 2 8-1 Part 2 homework solutions. In this one, we are focusing on geometric and experimental probability. For this problem, we are throwing a dart at this crazy-looking dartboard, and we're equally likely to hit any point inside the square board. They're giving us that. We want to know the probability that we're landing in the yellow region. So just to kind of get a setup for the yellow region, geometrically speaking, in general we have the target area divided by the total area, but this target area isn't just this yellow circle. It's this yellow circle minus all this stuff in here. So I'm going to be looking for my yellow circle minus a few things, minus this white square, for example, plus I also have two of these green triangles. And then all of that's going to be divided by the area of this big blue square that everything is on. So in terms of actual numbers here, our yellow circle, we can figure out that area by doing pi r squared, pi times the radius squared. So that's going to be pi times, well, let's see, if it's 18 inches across this whole thing, that means 9 is our radius. So pi times 9 squared. Minus the white square, that's going to be 6 squared, because one side of that is 6. And then two of these triangles, well, each of these is going to be 1/2 base times height. The base is 6 and the height is also 6. It looks like we have 6 all the way across there. So 1/2 times 6 times 6. And all of that is going to be divided by our blue square area, which is going to be 18 squared. And I'm just going to plug all of this into Desmos now. So let me make a fraction, and on top I have pi for pi times 9 squared minus, let me open a parentheses, and we've got 6 squared plus 2 times, let me put 1/2 in there, and then we've got 6 times 6, and close the parentheses. All of that divided by, let's see here, let me open this window up a little bit so I can see what I'm doing. There we go. Down there we have 18 squared. So that craziness is a grand total of 0.563. So there we are. On this one, we have a student losing his earbuds while walking home from school. I feel like this is a pretty common story here. The earbuds are equally likely to be at any point along the path shown. That seems reasonable. We want the probability the earbuds are on Cherry Street. So this is a geometric probability type of problem. We have the target area, which is just this 0.2 mile stretch of Cherry Street, divided by the total distance, which is 0.1 plus 0.4 plus 0.2, just the whole thing. And we'll do all that on Desmos. So we have a fraction, we have 0.2 over 0.1 plus 0.4 plus 0.2, a grand total of 0.286, which also incidentally comes out to about 1/7. For this problem, we have each section of the spinner shown here with the same area, and it's spun 20 times. Table shows the results. We want to know for which color is the experimental probability of stopping on the color, the same as the theoretical probability. So because we have 4 equal areas, the probability theoretically of spinning any of these colors is 1/4. Now let's do the actual experimental probability and see which one matches up. So we've got, let's see here, let's do red first. So we had 5 actual successes for that divided by 20 attempts. So probability of red on the experimental end is 5/20, which reduces to 1/4. So that appears to be our answer. But we have to look at the other colors because it could be more than one of them. So now we have probability of green. That's 9/20. Probability of blue is 3/20, and yellow is also 3/20. So in the end, red is the one that matches. On this one, we are rolling a 6-sided die 60 times, and the table here has the results of those rolls. We want to know for which number was the experimental probability the same as the theoretical probability. So the theoretical probability of rolling any particular number, since there's 6 of them, is going to be 1/6. So we're looking for the experimental that matches up with 1/6. So experimentally, we have for the ones here a probability of 11 over 60, which is close to 1 out of 6, but not quite. Then we have 14 out of 60 for the 2's, which we could reduce by 2 to be 7 over 30. Next we have 3, that's going to be 7 over 60. Next we have 4, which was 10 over 60, which does reduce to 1 over 6, so 4 definitely is our answer, at least one of the answers. There might be more. Let's look at the others. Probability of 5 was 6 over 60, which is 1/10. And then we had probability of 6 was 12 over 60, which is 1/5. So yeah, 4 is the only one that had the same experimental and theoretical probability. On this problem, we have an archaeologist uncovering 26 artifacts from a site. The types are shown in the chart below, and we randomly select an artifact. We want to know the probability that a piece of pottery is selected. So we have pottery here, that's listed at, this looks like 7 in the bar chart. So we have 7 over the total number of artifacts, which they said was 26. So 7 over 26. Which, if I plug into a calculator, also comes out to 0.269. And on this problem, we have a survey of 140 teenagers asked what type of food they like best, and they showed the results here. We want the probability that a randomly selected teenager from the survey likes Mexican food best. Well, Mexican food is this greenish sort of pie right here. That's 24. And that's going to be divided by, I would say 140, but just for fun, let's add these all up and make sure it actually equals 140. So we've got 39, 31, 24, 22, 10, and 14. Yep, it equals 140. So then all that stuff added together, 24 divided by 140, comes out to about 0.171. Or about 17.1% if you like.